So today we're learning two more shortcuts. Yesterday we learned what shortcut? SSS, or side, side, side. Okay, we're going to learn SAS and also HL. So those are going to be potential reasons for your very last step of your proof. Remember, there's a total of 5 shortcuts. And there's 2 more. So before we learn about SAS, we have to know what the word included means as far as geometry. So let's look at this picture. Angle T is included between TX and TD. So looking right here, we've got angle T right here. It is included in between these 2 segments. So it's sandwiched right in between them. You could also have a segment that's included between 2 angles. So if you look at segment DX, it's included in between these 2 angles. And now the reason that's important is this included word is in the definition. So if 2 sides and the included angle, so the angle right in between the 2 sides of one triangle are congruent to 2 sides and the included angle of another, then the triangles are congruent. So the picture that goes along with that, notice we have 2 sides, x, y, and xz, and the included angle right in between them is congruent to these 2 sides and the included angle on the other triangle. So the angle needs to be right in between the 2 sides that you talk about being the same length. Okay, and as always, the order of these letters will be important on the test. Questions on that? Okay, so let's try one. So there's 2 givens. Let's put those on the picture right away. YZ congruent to LZ and XZ is congruent to ZM. We should also put those as our first 2 steps, right? So we've got 1 and 2. Again, everybody should automatically do this on any quiz or test or homework problem where you're writing a proof. Always start with the givens. Up there in the prove statement, I have the congruent statement left blank on the second one. What order should that be in? Yes.
MLZ.
Yep, it should be MLZ. All right, now remember, we're always looking for 3 pieces of information before we can say the triangles are the same. We have 2 of them right now. We have a set of sides congruent and we have a set of sides congruent. Now the only other shortcut we've learned about side, 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 and we just mentioned side, angle, side. What angles would we have to say are the same? Yeah. The ones at Z. Okay, there's 4 angles at Z. So we have to either use 3 letters to name the angle, so I know exactly what angles you're talking about. Because notice there's an angle at the top, on the left, on the bottom, and on the right. So if you say angle Z, I don't know which angle you're talking about. So we could use 3 letters, or you could put numbers in the angles that you want to talk about. So let's do that, because that tends to be a little bit quicker. But you have to have them on your picture in order to put them in your proof. If you say angle 1 is congruent to angle 2 and you don't put them on your picture, I still don't know what angles you're talking about. So make sure that you label the picture so that I know where to look to say what angles are congruent. So we can say these are congruent because of what reason? Why would those 2 angles be the same? Yeah, they're vertical angles. Vertical angles congruent is a very common reason you're going to be using in your proofs. Reflexive and vertical angles congruent and given are the most common 3. So we have 2 sides that were listed in 1 and 2, and we have the included angle in step 3. So we have our 3 pieces of information. So what's step 4?
And we will put down triangle XYZ is congruent to triangle XYZ because SAS.
Perfect. Any questions on that proof? Proofs are still non-scary, right? Okay, with side, 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 and now side, angle, side. So very straightforward. You're just looking for those three pieces of information, then you can say the triangles are the same. Ready to move on? All right. HL, this is our third shortcut we've learned. HL stands for hypotenuse leg. So if we have a hypotenuse, what kind of triangles have a hypotenuse? Right triangles. So this shortcut only works if we have right triangles, which coincidentally is one of the three things we need to say if we use HL. Okay, so that's what I just said right there. Here are the three pieces of information. We need to say that there are two right triangles because it only works in right triangles. We need to have a pair of congruent hypotenuses and a pair of congruent legs. So those are the three things we put dots next to. Okay, so this would be a picture of what a potential HL problem would look like. Here's our hypotenuses. Here's the leg, congruent to the other leg, and we have right triangles. Remember, the hypotenuse is always the one across from the right side, right angle, I mean, the longest side on a right triangle. Ready to try one? Let's see what these ones look like. Okay. So here's the given. Let's fill in the congruent statement. We have CBD. So look at where CBD is named. What would the second triangle be? Yes. In the same order, EBA. So sometimes on quizzes and tests, I'm going to tell you the total number of steps on the proof, and other times I'm going to leave it completely blank. What do you think we should say for 1 and 2? The givens, okay? After we write them down, we'll put them on the picture. Oops, not B. All right, so we can put marks on there because those are congruent, which is something we need to say.
Would you say KE is congruent to CB then, since they have that?
We'll get to that. We'll get to that. Right here, number 3, why was I able to say that those two angles that have the squares in them, how did I know they were right angles looking at the step before that? What told us that?
Bisectors have to be like right in the
It's not the bisector part of it. Yep. The perpendicular, what does perpendicular mean? Right angles. Two lines intersect to make right angles. So the reason we know that they are right angles would be what reason? Definition of perpendicular. The perpendicular is what told us we have right angles. Okay, so far we still only have one piece of information that's helping us towards HL. All right. So if we have right angles in triangles, does that mean we have right triangles?
Yeah.
Okay, so let's say that. Triangle CBD and triangle EBA are right triangles. This is one of the things we need to say. We need to specifically state that we have right triangles. Okay, well, we have right triangles because we have right angles in them. This one is definition of right triangle. Anytime you're using HL, that reason has to be somewhere in your proof. You need to say that you have right triangles because it only works, HL only works if you have right triangles. So let's look at what we're missing. We have right triangles. What are these on the picture? They're the congruent, they are the hypotenuses. So what are we missing? The congruent legs. Let's look at this one because there's a little bit more information we could steal from this sentence. AD, we already used the perpendicular part. AD is the bisector of CE. So what segment got cut in half? I'm hearing both. One of them got cut in half. This is the bisector of this. So CE got cut in half. So looking at CE, that means we can say that the two pieces are congruent to each other if it got cut in half. Okay, so we can say CB congruent to BE. Those are the legs. How did we figure this out? What told us this? The fact that they got bisected, right? That CE got bisected. So yes, that would be definition of bisect. So on the right-hand side, you're always stating how you knew this. How did we know CB equals BE? Well, because we knew it got bisected. So the definition of bisect. All right, well, now that we have our three dots, our three pieces of information, we can say what we're trying to prove. What's our shortcut we used? Yep, it's right here on the left. Questions? Now, just because you have a right triangle doesn't mean that you're automatically going to use HL. Let me give you a picture example. Everyone draw this at the bottom. What if we had this picture right here? What could we use on this one? SSS. SAS. We have side, angle, side, side, angle, side. Okay, so this is an example of SAS. Remember, HL would look like this. So don't get in a trap of thinking, oh, right triangles, I have to use HL. It is possible that you could use a different one. Okay, but most of the time it turns out to be HL.
When you would use the SAS, that's when you don't have the hypotenuse.
Mm-hmm. Other questions before we try our last proof? All right, I'm going to have you guys, oh, we just talked about this. If two legs of a right triangle, just say see other page. Got ahead of myself there. All right. Only 5 steps on this one. I'm going to give you a head start on this. Fill in the givens and see if you can determine what a few of the other steps are. It does help to label your picture too, so you can see what information you do have. The two steps that aren't filled in right now are steps that you have seen before. Neither of them are new. Somebody remind me what I said the three most common reasons are. Yep. What's another one? What's the last one? Do you have any of those on here? We have given. Do we have any others we could use maybe? Always look for these two right here. Nearly every proof is going to have one or the other or both. Because they share a side, we can say they're congruent to each other. Okay, so let's do that. And you could do this in step 3 or step 4. Does not matter. Okay, so now that we have our picture with the markings on it, we can maybe see the direction we want to go. We so far have 3 shortcut options. Which one would we use according to the picture? Yep. Okay, so if we were doing side angle side, let's just look at this top one right here. We would need to know if this angle was congruent to this angle. Do we know that? How come? If I told you that the left and the right were parallel, we could totally use that reason, and we will coming up. So I'm glad you brought that up. But I didn't tell you that these were parallel on the left and the right, so we can't say that they're congruent yet, but we are going to use that reason coming up in another section. So we're not going to use SAS. What do you think we're going to use? Okay, let's talk about HL. Do we have congruent hypotenuses? Which ones are the hypotenuses? Right here. So we have congruent hypotenuses. That's what we said in step 3. Do we have congruent legs? Yeah, the ones on the left and the right are legs of the right triangle. What's the only thing we're missing in order to use HL? What's step 3? Or in this case, step 4 on our proof. What do we have to say? We have to say that we have 2 right triangles. We haven't said that yet, so let's do that in that step. So triangle DAB and triangle BCD are right triangles. What was our reason for this step on the other proof that we did? Definition of right triangle. This step right here, step 4, has to be in your HL proofs. Obviously the letters of the triangles are going to be different, but everything else will be the same. You have to say that you have right triangles. So what reason did we use? Yeah, our shortcut on this one was HL. Questions?